Hi, I'm Bruce Bell from Pass It Homes. I'm the Managing Director and Founder. So I want to talk to you today a little bit about what we're doing. So the house building industry is about to go through a massive transformative change. The UK as a whole, society is changing. We're becoming less and less skilled and more educated, which proves a big issue for the house builders who build using very traditional techniques and skill-based construction. So there's a lot of focus at the moment on prefabrication, factory manufacturing as an alternative route to solve these problems. But we can see that that's only going to make up a small percentage of the market, even if they're successful. So the question is, what happens to the other 95% of projects? How can we resolve and make change in them? So we're looking at how we can integrate digital tools into traditional building techniques. And that means, how can we do it on a small project with a small budget? This is what we call digitizing the analog. So first I want to talk a little bit about manufacturing. Why do we manufacture? We manufacture because it delivers consistency and quality, which is what you don't get with things that are made purely by hand. And then we can ask, what is a manufacturer? So here's a few examples of companies that manufacture. They design, they develop, they prototype, they do the research and development, but they deliver to the customer by a single company. And that's quite important. That gives the customer reassurance that it's going to work, it's not going to fail, and it leaves the responsibility with a single company. And then we can say, okay, so manufacturers, what do they actually make? Now, bicycles are a good example. This is Brompton. So these are the parts that they actually make themselves, whereas these are all the parts that go up to make a bike. So there's lots of parts in there that are possibly custom made for them or just purely off-the-shelf standard parts. But they make sure that they all work together in harmony and work for the customer and are good quality. So they're using, and all the bicycle manufacturers are using, digital technology throughout the production process, from concept through to completion, in supply chain, in prototyping, in manufacturing. Digital is prevalent throughout the entire process. So when we come into houses, there's an assumption that to manufacture, you have to have a factory. So this is a little case study. Now, Legal & General have moved into construction industry and homes in general. They've just set up, which I think it's nearly completed now, the biggest production facility in Europe. They put in £55 million to a 555,000 square foot facility up in Sheffield, and that facility is going to produce 3,000 homes a year. Now, 3,000 homes is not a big amount of houses in the construction industry as a whole. We're hopefully meant to be delivering 250,000 homes per annum. So if we were going to follow this model and let's say build 50,000 homes a year using this, what would it look like? And actually, if you work it out, it would look like nearly £1 billion worth of investment to set up the facilities. It would look like over 9 million square foot of factory space. Now, I did a little bit of research, and that is nearly a third of all the available warehousing in existence in the UK. So there's some fundamental flaws there about being able to be rolled out on a large scale. So we're going to be looking for alternative methods. Factory manufacturing will be a part of the solution, but there is a larger problem there. This is one of the things that we've been working with. This is our own manufacturing facility. So it's digitally controlled manufacturing machine, CNC router, fitting in a shipping container, and we're taking our digital manufacturing facility to the construction site. So that means we're removing the overheads of the factory, removing the logistics, shipping, rent, overheads, and it's inherently scalable. So, you know, just one example of how you can kind of remove the factory from the equation, but start to involve digital manufacturing. So we're taking the digital production process through the entire story. So we've got our digital BIM model, which I'll go a little bit more in detail in a second, but we're taking from it assembly instructions, machine code, specification, bills of quantities, production schedules, all of those are being split out to various people. So third-party manufacturers, such as our window suppliers, get actual final production information straight from our BIM model. We're stripping out information for even traditional tradesmen, such as plasterers and plumbers. All that information is coming straight off the BIM, and they're getting bills of quantities. And then we're controlling the entire production process using the digital tools. So making sure that all the components arrive on demand as they're required during the construction process, and then digital capture of the projects back into the digital model or back into the studio. So just going to explain a little bit more about the kind of digitizing the analog process. We're starting with very straightforward customers with sites. We're designing houses for them. Each one has a set of constraints, desires, budgets, and we're starting just as any designer would do, with ideas and thinking and dialogue and sketching, creativity to start to formulate the designs. We're going through these with the clients, making sure they're engaged with this, but very quickly we're moving into the digital format. So we go quite early on from concept stage right into the BIM model. We're using Autodesk Revit, and we're designing the houses and fleshing it out. Using visualization for the customers. We've started using Enscape, which is an amazing plugin for Revit, so that they can engage with the designs, and actually we can use it as the design tool going through to make sure we understand exactly what the product is. Obviously, the BIM environment enables us to model components, families. We've created our entire set of library components within Revit. For our own manufacturing purposes. I mean, this has been mentioned earlier on by Martin, but where we're really starting to change things is taking this data and actually manufacturing goods with it straight from the Revit model. So this is one of our components in detail, and every single detail is worked out, and we're doing static load testing, production prototyping, to make sure that the components that are in the Revit environment are true and are accurate. Each one is parametrically controlled, so the design team can change it as they require. We're not limited by the tools. We're creating ourselves design tools to be able to deliver the project as a whole. We're creating assembly instructions for each component, so they're quite detailed in terms of the manufacturing, but actually very simple to put together, simple assembly process. So we're following manufacturing techniques of design for assembly, where we're really focused on how these things are going to go together at the same time as we're designing it. That's more assembly components. And then we're sending all this information to the building site. That's our manufacturing machine on site. We've got materials arriving. We've got digital code going into the machine. We're manufacturing and assembling, all in sequence, all at the right time. We're collating all the waste, and that's all going off to be recycled. The components themselves, digitally cut, very accurate, hand assembled. So we're getting the maximum out of the machine, minimum costs, and we're making the use of the low cost of the construction site, which is why at the moment, 99% of most construction, particularly in housing, is done on site. It's because it's low cost. And then we're using other digital tools. So we've created ourselves a Facet Wiki, which is the how-to book of how to do things. And this covers design and construction simultaneously, so that the people on site both understand what they're supposed to do, but also why it is like it is, which is quite important, so that people can really get in. And that goes for the design team as well. The design team are looking at what it is they're supposed to be designing, the rules that they're supposed to be following, but also why they're like that and how it's going to be constructed. So we're using simple Google Sites to do a wiki, very simple for the design team to update. Everybody in the studio contributes to it and keeps it up to date. And then on site, it's big wooden Lego. So just like Lego, you have standard bricks, and then there's those funny little knobbly bricks that go on the top that are something special in that design. Exactly the same with us. A lot of standard components, but then every project has custom-made junction details, parapets, or something special, or custom-made features. And we're trying to get that real high level of precision and detail to get the products that we want. The tools are there to enable us to do good designs and to enable us to do the designs that we want without it being a massive headache. We're also using other tools such as Google Hangouts for team engagement. So, so I can see the streams from each of the projects, and I can see errors and issues on a kind of internal public format, so that I can kind of make sure that things are picked up and we change the design to resolve the things, and they don't go undiscussed within the studio as a whole. Another thing that we started using, which came from a research project a few years ago, the Ricoh Theta camera. It's a 180-pound camera, 360 degrees. We now have regular uploads of data capture. So one of the problems is if you ask somebody to take a photograph of your project who's on site, they will take a photograph of what they think is important, whereas actually the design team, we just want to capture the whole thing. Now, our projects are small. We can't do data scanning on a large scale because it's so expensive. This, we take an instant photograph in every single room and every single position on the outside of the building, upload it onto our shared data, and then we're able to do virtual site visits within our design studio from senior people in the team. We can go through, and you can see pretty much everything. And they're not super high resolution, but you can see most construction details. The only thing it wouldn't do is pick up kind of small scuffs and plasterwork, that kind of thing that you might, you're going to have to do on site. But we can see everything within our studio for virtual site visits. And it's the beautiful thing about it is it's unselective. It gives us everything. And if we ever have a problem and need to unpeel the layers and go back to a position and say, where was that cable or that pipe? It's all there. And we're controlling the traditional processes from within. So the facet chassis, the components that we make, are incredibly detailed and accurate. And then all the other trades that come on site, they're all traditional. There's still plasterboard going on, plasterers and skimmers and plumbers, but they're all putting it onto the chassis that we've made, which is incredibly detailed. So all of those fiddly details and parapets and furrings for drainage and all that complicated stuff, integration for MVHR services, it's all there, so it's a very simple, de-skilled process for the people on site. We're doing product development for other elements of the build, so we're doing cladding and staircases and other details. We're doing production prototyping for most anything new that we're doing. So this is a solid shade detail, so laser cut components straight from our production process, out to a third-party manufacturer, back to us, prototype tested, and then going into final production, all within a very, very short space of time, because these tools are very cheap and available. And then we're doing the final finishes using the same technique, so CNC manufacturing of cladding components, timber, whatever it is. Generally don't do that for everything because it makes it expensive. We're still using quite a mixture of quite simple components and simple cladding techniques as well as the detailed stuff. And this is, this is the aim of the game, and it's been mentioned today as a digital twin, which is new to me, but it's that thing where, the reality matches exactly the virtual, and that's the point. We're trying to get that built as designed. So everything on this, down to the millimeter, is exact. The time of day, the shadow, every single parameter is exact. And for building projects on a small scale, on a small budget, that is really unheard of. It doesn't really happen, and it's only possible because of the digital tools. So again, digital, real, and we're doing really interesting homes for real people, private clients. Everyone's different. Everyone has a different set of parameters, and delivering a kind of wide variety of homes for different people. And we're actually showing that you can do this. You can take these digital tools and transform what is a very, very traditional process. And that's the end. Thank you very much.